Yeah, hello, good morning. Hi. Thank you, Sasha, for the invitation. Yeah, so before going into elastic electronics and how this was converted to a great project, I'll just shortly brief who we are. So we were founded in 1980 in Porto, like Sasha was explaining. So our company is mainly an automotive supplier of plastic components. We do not only injection molding, but additive manufacturing, also an assembly process. This is a short video of, we are 42 years old, but 6 years ago, we lost everything, as you will see on this in a couple of minutes. So we had a fire who completely destroyed our factory in just like 30 minutes, which is something quite fast. But yeah, luckily we were able to get strength, we don't know where, and come back on track. So 1 year after, by the beginning of 2018, just 1 year after the fire, we had a new plant ready for manufacturing, and the production just got started. So, but this also changed a little bit our minds and the way how we work, because luckily we are good 5 years after, but also, and moving by, as we are automotive, not only exclusively, but 70% of our business is dedicated to automotive industry, we should also find ways how to develop ourselves. So industrially, we were able to come back. But what about our products? And this was the question. So namely what we do daily, on a daily basis, is this is a traditional car interior, as you see it almost today. Standard positions, a little bit of lighting and electronics, but as you know, things are moving on this direction with lighting as we have it at home, amazing screens with more than 1 meter, and also the position that you have inside the car is changing due to autonomous driving. So of course it's really cool to have seats everywhere in amazing positions, but this also is going to change the limits of our materials, because moving into this direction forces us also to change the way of constructing not only plastics but fabrics and the integration of everything. So in 2021 we started to search a way how could we transform our components and making them more unlimited for what is coming. So based on the technology that we are here presenting, basically it's a family of patents. It's an ink. Conductive inks are not world new. But what is great about this ink, it is, first, it's highly stretchable. We can stretch it 10 times. So it's there. We have a world record on this. There is not an Olympic game for stretchability for elastic electronics. But yeah, it has. And also the second thing, which is really cool, is that we can add LEDs or Bluetooth or any SMD component to the ink and keep the stretchability. And at the end, it's great because it's recyclable. So patent number 1 is, of course, about the ink itself. Which is also cool is that it's a sinter-free process. So the ink is conductive immediately after printing. So no need to heat or sintering steps afterwards. You have it conductive ready as soon as you print it. Also it's stretchable, and we can add it to any material. And when I say any material, we have a showcase with traditional fabrics, alcantara or plastics or wood or wherever, because we can adapt the formula to glue it. It's not to glue, but to glue it to any material. And this is cool because also in terms of strength, we are able, against to the other inks on the market, to keep the resistance on a stable level, even if we increase the strain. And also, if we do several cycles, we are also, in terms of resistance, stable, even if we stretch it a lot. So the idea is to create electronics that can bend, that can twist, that can stretch, and also maintain their electrical properties. The second patent on this is the way how we can integrate SMDs or electronic components on the ink and keep the stretchability. So this is, we have a short video coming, which is grabbing LEDs into the ink, making elastic movements and keeping the process. So also on any other electronic device. And at the end, as I was telling you, we can recover back the components by a chemical process, which is cool because also you can get back the LEDs, you can back the metals from the ink, the film where we used it, and also the electronic components. So here you see on the left side, so on the right side, a traction test, and it's quite amazing. And here on the left, we just cause a cut on the ink, and through this patent process, we will cure and heal the ink and get back the electrical connection afterwards. In the process, this is 1 times augmented. And after healing the connection with the ink, this is able to recover the elasticity properties at the end. So finishing the healing process and getting back the light on the LED. This is the position where the cut was previously made, but you can stretch it again and have the same properties at the beginning. So, but how moving into automotive industries? So this started as a health monitoring technology development. So we have a short video with sound. I don't know if it has sound or not, that I will show it. So the Unique 2 project, interior car concept that we launched in Hanover just in June this year to showcase. So with this concept, what we tried to create was different applications of the technology that we have here. We have the steering wheel and the center console, but exactly doing the same process that we have with the ink itself. So on the seat, we change a normal textile fabric or Alcantara simply by printing our technology over it, and we can remove a lot of buttons and switches and transform a normal fabric in a way how to move your seat up in front. Also on the steering wheel that we have, so we could create with 3D laser engraving to give you on a normal plastic part, but on the back integrate 3D shapes for Spotify, volume, changing your playlist or light dimming effects. Also on the same part with a small footprint. And here on the right side, the center console, having the same properties, normal fabric, but you can have the interact with the HMI interface or buttons and sliders. And that's it. Any questions that arise from you, I'm happy to answer them. Thank you.